Hi everyone, for this question, given the function hx is exponential and kx is ln x, logarithm function, where x have to be greater than 0 means positive. First, find the composite for hkx, then deduce your answer and hence sketch the graph on the same axis. So first of all, we need to answer the composite function where hkx. So substitute kx, which is ln x, and then substitute this ln x into the function of hx. So this x will be replaced by ln x. So it will be e ln x. Then we simplify this operation. E to the power of ln can be cancelled, so we get x. Once we get the composite answer, which is x, so from here we can get a relationship. So this one they want us to deduce our answer, means that what's the relationship between this function hx and kx. So since composite result get x, therefore we can conclude that their relation is inverse to each other. So hx and kx, they are inverse to each other. Then from here, we can add on some extra question where the question might ask, what is your H inverse? So we know that the composite we get x. So this brings that they have special relationship. They are inverse to each other. So if you want to find H inverse, we cannot recalculate the whole operation. So from this relationship, we can know that H inverse will be equals to Kx, which is ln x. So either they can ask us what is your H inverse, or they also can ask us how about your K inverse. The function K inverse, of course, will be equals to our Hx, which is exponential. Alright, so we back to the questions. Then we're going to sketch the graph on the same axis. So we know that they are inverse to each other. So when you want to sketch their graph on the same axis, means we sketch the exponential function. Then we inverse, means we redo the refraction, so that we show that this one kx is the inverse function. Their relationship is going to get from the concept of refraction. So first of all, we draw out our x-axis and y-axis. And the first function that we want to draw here will be our hx. So hx is exponential function. Domain, it is always negative infinity in infinity. Their range, when we close this exponential, we get 0 to infinity. So means that y equals to 0 is our asymptote. So we have an asymptote here. And then the graph is going up here, and power to the x is positive, so it will be shoot up to the right. If you want only drawing exponential, then it's okay. But for this concept, we still need one more things to do, is we have to show out our kx. So our kx function will be obtained by using refraction. So when our axis of refraction come in, we have to consider whether our exponential is it cross over our refraction axis. So refraction axis is y equals to x. So what's mean by y equals to x? Mean when your coordinate is 1. For y equals to x, so your y will be equals to 1. When your x equals to 2, your y equals to 2. So let's check our functions here. So we can take our table mode, put in our exponential function, and then we enter. We will calculate, maybe we need to focus is the positive part, because we know our exponential for the graph here is always at here. Just we don't know whether we're going to overcross or just shoot up. So we can test our value, start from 0. So we want to see what happened to this part. So start from 0, ending, we just guess, let's say ending by 5. Step means what is their scale. Maybe we put 0.2. So we can see when x 0, it is 1. When x equals to 0.2, it will be 1.2. Then, so you can see the y coordinate here, it always greater than x value, this one. For the axis of symmetry, the y value is always same with x value. But for our graph that we want to calculate here, the y value always greater than the x value. Means that it will always shooting up. So it will not be the case of going below than y equals to x. So if our graph going below y equals to x, means our y coordinate here will be less than our x coordinate. So you can see when you have 1.8 something, your y coordinate already shoot up 6 point something, and so on. So they're always shooting up. So you will not go under the axis of refraction. So this is our exponential. Then we label when x is 0, y is 1. So this is our original function, hx. Then to draw another graph on the same axis means we need to do our refraction to show that kx is the inverse of this hx. So for now, we are going to refract it. Firstly, for the horizontal asymptote, we do the refraction. It will become vertical asymptote for x equals to 0. And then for this graph, we're doing the refraction. So this is the side, then passing to value 1, and then shoot up. So try to make it symmetry as possible. So you can always refer here, is it symmetry, is it same distance? This is the symmetry. This is our refracted graph, means this is our inverse graph, and this is our kx. So this is the meaning for this question. Sketch the graphs on the same axis. Then lastly, double check our graph whether it is labeled completely with x-axis, y-axis, intercept, asymptote, then origin, axis of refraction, then the name of the function.